Okay, you got a dot at 1, you got a dot at 3? Okay, connect. Now it says now connect the 2 points. So right here, connect these 2 points. When those dots are connected, okay? When the dots are connected, the domain is not the numbers 1 and 2 and 3. Well, not 3, obviously. It's not the numbers 1 and 2. Because when we connect the dots, that means all of these numbers in between also count. So my range isn't 1 and 2, it's from 1 to 2. So it's everything in between. So how do we say that? How did we say that my new domain is between, can you put your phone down, please? 1 and 2. Well, mathematically, you have already done this. When we talked about compound inequalities, we said it like this. This is the mathematical way to say the word between. So I want this to be any number between 1 and 2. So we're going to go 1 and 2. Okay? Now we're going to take that level, we're going to take that and we're going to make it 2D. Okay, that's one dimension because it's only right to left. Okay, we're going to make this 2 dimensions. So I'm going to plot the point 1, 2 and plot the point 3, 4. And what we have to do is the domain and the range. So we're going to go x can be any number between, and y can be any number between. Okay, and how are you going to figure this out? One way to do this is to do it just like we did before for domain and range and put my arrows down. Right? So we took arrows. If we wanted to know my x numbers, okay, this is your x-axis right here. And we can label those. I, again, did not put numbers on those for you. And really all you need is you need the starting number and you need the finishing number. Right? So where does this start and where does it end? So on the x-axis, which is your left to right, where does this thing start and where does it end? 1 and 3. So it starts, and you can do this. Look here. Point down at where it starts. Point down at where it ends. This is just one way to do it. We're going to talk about a different way to do it in just a second. So 1 and 3. Now, you don't need to have those arrows if you don't want. If you can figure out, like, how far left does that go and how far right does that go, those are the 2 numbers that you're going to use. Okay? So then how do we figure out the y? Yeah.
The other way. Why wasn't the first one 1 between 3?
Oh, you're right. Thanks, Vinny. Between 1 and 3, because it was, I plotted 3. Thank you. You are correct. There.
You go to the left.
For the next part, right?
Yeah.
So for the next part, to find the y's, I'm going to take my arrows and point my arrows to the left. So again, I didn't label these for you. So if you want to label up 1, 2, 3, 4. Okay? Because all you're looking for is what's the bottom number, and then what's the top number. So the bottom number of this graph, this thing that's graphed, is 2. But again, if you can't see where the bottom is, you can make that arrow over to the left or to the right, okay, over to the y-axis, wherever the y-axis is from that point. and then make the arrow over to the 4, which is just like what we were doing before with the dots, okay? But do we have to list out every single dot? No. We just have to list the biggest and the smallest for the X's and the Y's. So we've got, what did we say, 2 and 4. Okay, so here's what we're going to do. Our job today is to practice this with different pictures. Okay? So in general, it says right here, in general, when the points are connected, you are going to use this notation. So this is our between. And for us, okay, it doesn't always have to be this way, especially when you get to Algebra 2, but for us, for now, all of them will be filled in circles, so all of these will have lines underneath. So all of our circles will be filled in. Later on down the road, you can have circles that are not filled in, right? That's why we don't put the line underneath if it's not filled in. But all of our circles will be filled in, so they'll all be equal to's. Okay. So the domain, that's the one that goes left to right. So what you're looking for is how far left does that function go. So this is either the smallest x number or the left number. So how far left does that function go, whether it's positive or negative? How far left? And the top, or on this side over here, is how far right does it go? So what is the farthest number to the left that I can use, and the farthest number to the right that I can use? Okay. Then for the y's, you can either put the top number and the bottom number, or you can put up or down. I don't care how you write it, but it's the bottom number for the function, or how low the function can go, or how far down it goes. Any of those words are fine. So the bottom, which is going to be down, and then this is the top, or how far up. Okay, so our first example was super easy because everything in the example was in the first quadrant. So everything was positive, positive. Okay, so when we look at ones here that are not all in the first quadrant, there might be, we're going to look at a little bit different method to finding the domain and the range numbers. Okay? So first thing you're going to do is you're going to notice the points are connected, and if the points are connected, I'm doing this. Okay, so you can set that up right away as soon as those points get connected. Okay? Okay, now to help you see this a little bit better, okay, it's a little bit hard to do the arrows, especially when some arrows are going to go, wait, do I go up to the x-axis? Do I still go down? What do? I don't know. So another way to do this is to put a box around this function. Okay, so I have some highlighters we can pass out. If anybody wants a highlighter, we can pass out these highlighters, but this is what you're doing. You're putting a box around the function. That helps you see how far left it goes, how far right, how far up, and how far down. Okay, so the box, you start at the bottommost part of the function. It does not have to be a dot. See over here, there is not a dot at the bottom of this function. Do you see that? There's no dot, but that is how low that function goes. So we can start by putting a line there. So you start at the bottom of this function, and you go right or left until you get to the edge. This function doesn't go any farther to the right than that. So now I'm going to go up. Go up to the top of the function. Now I go left. And then I go here and I complete my box. Okay? So go ahead and put a box on the next one. Once you get that box, try to put a box on the next one. Okay, you got your box? Okay, so we've got that box. So now, I know we didn't label every single number here, but we labeled enough that you can tell. So this is 1, this is 2, that's 3, this is -1, -2, and -3. So on the x-axis, what is the furthest to the left and the furthest to the right that box goes? So we've got -2 on the left. That's where it crosses on the left. And we have a +3 on the right. So we're going to go -2 and 3. Okay, so you see how where your box crosses, that's going to give you your numbers. Okay, now we have to figure out top and bottom. Okay, what's the lowest point that this box goes? Where does it cross there? Well, this is a -1, 0, 1, and 2. So it's at -1 and 2. Now we're going to put a box around this next one. Okay. So how far up or down or right or left? Start on one of the sides. So the bottom of the graph is right here.
Go to the 5.
Yep. And then I'm going to go up,
4.
over, and down. So we've got a 1, 2, 3, 4, 5.
Yep. And that one.
So my domain is going to go from 1 to 5. So that's what the box is for. It should show you the start and the end, the left number and the right number on that x-axis. And because the dots are connected, we're still doing this between notation. And you can still put the arrows down on the 2 circles on the end, but what if your dots aren't at the bottom or at the top? That's where it gets a little bit hard to do the arrows like we were doing above because there's multiple points. Okay? So then for this one, for the y, sometimes we forget that we can use the number 0. So we have 0, we have 1, we have 2, we have 3, we have 4. So that goes from 0 up to 4. Okay? Our job in class today is to finish page 7. What we just went over here is for problems 1, 2, 3, and 4. Do not do number 5. I'm going to give you a minute or two to do problems 1 through 4 before we go on to number 5. I want to make sure everybody's good with this before we move on, okay? So you're just looking at 1, 2, 3, and 4.
Somebody's good.
start by drawing a box. Draw a box around each one of them.
These are different.
Yes. I just want to point out one thing here real quick, okay, to the whole group. Okay, so a couple of things. When you draw your box around these, the box must include the entire picture. Okay? So when I do my box, especially for this one's kind of tricky. Make sure you go all the way up to include this little curve here at the top. Okay, so include the whole thing. Okay, I'm going to go on to the next little piece, but I promise I will check that. Okay, next little piece is on page 6. Okay, did you notice that when I asked you to stop at number 5, what's different about number 5 than number 4, or number 3, or number 2, or number 1? It has an arrow. So back on number 6, we're going to talk about how do I deal with arrows. So the first 2 has 1 arrow, the second 2 have 2 arrows. So what do we do when we have 1 arrow? Well, remember, we're drawing a box around this, right? Here's the thing. An arrow cannot be contained because an arrow means I'm going to go on forever. Okay? So when I draw this box, there is no arrow on this end, so I can box in this side. But can I box in this side? No, because you cannot box in an arrow. So this side cannot be drawn on there. So I'm going to just do an arrow. Okay, do this with me, otherwise you're going to get super confused. Okay, so I start at the end here because this actually has an end, and I keep going this way. Why? Because I cannot box in this side. It'll break through my box and keep going. So if I say that that's the domain, I will have lied because it broke that barrier and it kept going. Okay, then here I'm going to go up. But can I put a ceiling on that one? No, just the same as I can't put this side, I can't put this side either. Okay? So when you have an arrow, these 2 sides cannot be boxed in. So there's going to be nothing there. So the 2 sides around the arrow, you can't box that in. Keep those open. Okay? Okay, so then what do I put? Right? Are the dots or are these points connected? Yes. So you are still going to do your setup like so. All right, so set that up for me. Let's talk about the X numbers first. Okay, the x number here is 1, right? But then this goes on forever. So the smallest number is 1, 2, 3, 4, 5. What do I write if it goes on forever? What is the number for forever? Infinity. Yeah, so this guy is going to be infinity. So it goes from 1 to infinity, because infinity means forever. Okay, so it goes on forever. So when I write down my x's, I'm going to have a 1 and I'm going to have an infinity. Okay, now we do our y's. For the y's, so look over on the y-axis. Where does this thing start on the y-axis? Starts at 2. So I'm going to write the number 2 on my y-axis. Where does it stop? It doesn't. It goes on forever. And what do we write when we write forever is infinity. Your infinity symbol does not have to be beautiful. Mine aren't. That's not even perfect or anything. So another way to do the infinity symbol is to just do a sideways 8. So you could put like 2 circles next to each other. Okay, so if you struggle to draw that symbol, you can just do 2 circles next to each other, kind of like an 8. So that one starts at 2 and goes to infinity. So those of you who are going on to number 5, there's a reason I was like, "Ooh, stop. We got to do this number 5 real quick before you do that one." Okay, so let's talk about this one, domain and range. Let's set it up. The points are connected. So let's set it up with our x and our y. And then we'll put the sides of the box that we will put those on there. So where there's an end point, like this one right here at 0, those 2 sides can be boxed in. Those 2 sides, we are going to put those 2 sides on there. But the side that comes here and here, those cannot be there. Okay? So when we draw our box, we can go from 0 and show that we're going down in this direction. I don't know where that's going to end. And then I can go from 0 and go in that direction. But I cannot put a box on the 2 sides where that arrow ends. So starting at 0, I can go in this direction. I can go in this direction. I am not allowed to put any sort of box there. So that arrow is going to break through that box and it's going to keep going. So this goes from 0, and anytime there's an arrowhead, that is positive infinity. Here is 0. If I go down, that's negative. Is negative positive infinity? No, it is negative infinity. Okay. So our x's go from 0 to positive infinity, and anytime you have a negative infinity, that's going to go over here on the left. And my 0 will be the top number. That's the top number in this case. Okay. Awesome. Thank you so much. Go ahead and put your binders away, and we will finish that page 7 tomorrow.